Hi everyone, in this session we are going to discuss about application of stack, that is infix to postfix transformation, means how we convert an infix expression to its postfix equivalent. So for that, here you see an expression a plus b. It is an infix expression, means in this expression a and b are the two operands and plus is the operator. So the operator is placed between the two operands. So this is known as infix expression. Next is the postfix expression, also known as reverse Polish notation. In this, the operator is placed after the two operands. That is known as postfix expression. So this is the postfix equivalent of this infix expression. Next is the prefix expression, also known as Polish notation. In this, the operator is placed before the two operand. That is known as prefix expression. So it is the prefix equivalent of this infix expression. So for evaluating an expression, we need to know the concept of precedence and associativity. When an expression contains more than one operator, then the order in which the operators are evaluated depends on their precedence and associativity, which is from left to right or from right to left. But if the precedence level is same, then the order of the evaluation depends on their associativity. So here you see arithmetic operators plus, minus, divide and multiply. Their associativity is from left to right. Next is the increment or decrement operator and their associativity is from right to left. So in fixed expression we can say that they are readable and solvable by humans. We can easily distinguish the order of the operators and can use the parentheses to solve that part first during solving expression. But the computer cannot differentiate the operators and parentheses easily. That's why postfix conversion is needed or prefix conversion is needed. So there are also some difficulties in dealing with infix expression. The difficulties are that there is a great deal of ambiguity in finding the value of infix expression. So you see here an example of infix expression 10 plus 8 into 6. So in this expression, this is evaluated from left to right. So first preference goes to this multiply operator 8 into 6 and then added to 10. So the final value is 58. The same expression, but we put parentheses here. So the result of this expression is 108. The value is same, but result is different. So this is, we can say, the ambiguity in finding the value of expression. So to overcome this problem, expressions are evaluated by using one of the two forms, that is postfix and prefix. And the fundamental property of these two expressions is that the order in which the operations are performed that are completely determined by the operators and operands in that expression. Both these expressions completely eliminates the need of parentheses. So we can say that in postfix as well as in prefix expression, only operators and operands are there. There is no parenthesis in prefix and postfix expression. So you see here, infix expression, its postfix equivalent and prefix equivalent. So a plus b into c, this is an infix expression. So how we convert this into its postfix equivalent? Similarly, you see here how we convert this into its prefix equivalent. So first of all, these two operands are here. The operator is placed after the two operand in postfix expression and placed before the two operand in prefix expression. Now you consider this as a complete operand. So a plus and this operand, again the operator is placed after the two operands. So this is the way how we convert infix to postfix equivalent. Similarly, one operand and this operand, the operator is placed before the two operands. So this is the way how we convert infix into its prefix equivalent. Similarly, this expression, how we convert these into postfix as well as in prefix equivalent. So to convert infix expression to postfix, we use a stack that holds the operator during conversion. The reason for using stack is that it reverses the order of the operators in the expression. That's why it is the application of stack. Using stack, we can convert an infix expression into its postfix equivalent or prefix equivalent. This is just an example. Now, so here is the algorithm how we convert an infix expression to postfix form. So first of all, the first point, push left parenthesis onto stack and add right parenthesis at the end of infix expression. Now, in the next step, we scan the infix expression from left to right. Means character by character, we scan the expression from left to right. If there is an operand, then we directly add to P, which is a postfix expression or postfix equivalent. If there is a left parenthesis, then we directly push it onto stack. You remember all these points one by one. Now, if an operator is encountered, then pop from stack every operator and add to P until stack does not empty. Actually, the meaning is that if an incoming operator has higher precedence than the operator on the top of stack, then we directly push the incoming operator onto stack. The next point is that if an incoming operator has lower or equal precedence than the operator on the top of stack, then we pop from stack and add to P, the operator which is on the top of stack, and then push the incoming operator onto stack. So you remember these 2 points. So before adding to P, make sure that the priority of current operator is less than or equal to the priority of the operator popped from stack. If right parenthesis is encountered, then we repeatedly pop from stack and add to P until left parenthesis is encountered, and then we remove left parenthesis from stack. So these are the steps, means an algorithm to convert an infix expression into its postfix equivalent. So here is the example. You see how we convert an infix expression into its postfix equivalent. So symbol scan means we scan this infix expression character by character from left to right. So you see here A plus B minus left parenthesis C plus D, right parenthesis divide E into F minus left parenthesis G plus H, right parenthesis divide K, and right parenthesis. Here is the stack and here the postfix equivalent. So the first step in the algorithm, we first of all push left parenthesis onto stack and add right parenthesis at the end of expression. So we scan this expression from left to right, character by character. So first of all we push this left parenthesis onto stack. So the first symbol is A, which is an operand. So we directly add to the expression. Now next is the operator. So we push this operator onto stack because at the top of stack there is left parenthesis. There is no operator at the top of stack. Next again the operand. So again we add it to the expression like this. You see here. Again the operator is uncounted. So first of all we check the operator at the top of stack, and top of stack is plus, and the precedence of plus and minus is same. So it means first of all we pop this operator from stack and add to the expression, and after that we push this incoming operator onto stack. You clear this point in the algorithm. Next is again the left parenthesis. If left parenthesis is encountered, then we directly push it onto stack. Next is the operand. So we directly add to the expression here, that is C. Next again is an operator. So here you see at the top of stack there is left parenthesis, no operator. So at the top if there is left parenthesis, then we directly push this operator onto stack. Next is the right parenthesis. So in the algorithm, you remember that point. If right parenthesis is encountered, then we repeatedly pop from stack and add to P, which is a postfix equivalent. So at the top there is plus operator. So we pop this operator and add to P until left parenthesis is uncounted, and then we remove the left parenthesis from stack. Next is the operator. So you see here at the top of stack there is minus and the incoming operator is divide, but the priority of this incoming operator is higher than the operator on the top of stack. So we directly push this operator onto stack. Next again is the operand. So we directly add this operand into postfix equivalent. Next is the operator, but the operator at the top of stack has the same precedence as the operator uncounted. So it pop from stack and add to this expression. Next is minus, but minus has lower precedence than this incoming operator. So we push this operator onto stack. Next is operand. So again we add this operand into the postfix equivalent. Next in operator is uncounted. So at the top of stack we see here that is multiply operator, and this has the higher precedence. So we can pop this operator and add to the expression, and next is the minus. Again this operator has the same precedence as the incoming operator. So it also pop and add to this expression, and then we push this operator onto stack. First this one is popped, so we add this first, and then this one is popped, then we add this operator. Next again there is left parenthesis, so again we directly push it onto stack. Next again an operand is encountered, so we directly add it to P. Next again an operator is there, but this time at the top of stack there is left parenthesis, no operator is there, so we directly push this operator onto stack. Next again an operand is there, so we add this operand to the postfix equivalent. Next right parenthesis is encountered, so we repeatedly pop from stack and add to the expression. So top is plus, so we pop from stack and add to this expression until left parenthesis is uncounted, and then we remove the left parenthesis from stack. Next is divide, but divide has higher priority than the operator on the top of stack, so we directly push this operator onto stack. Next is the operand. So again we add this operand to the expression. Next is the right parenthesis. So we directly pop from stack and add to P one by one until left parenthesis is uncounted. So first divide is popped. So first of all we add divide to P, and then minus we add to this expression, and finally we remove the left parenthesis from stack. So after that there is no symbol, so stack becomes empty, and this is the postfix equivalent of infix, given infix expression. This is the way by using stack we can convert an infix expression to its postfix equivalent. So thanks for watching this video.